Welcome to the Explainer. So if you've ever worked with Kubernetes, you know that getting your application actually connected to the outside world, well, it can be a real headache. Today, we're going to dive into Kubernetes' brand new official solution that is, frankly, a total game changer, the Gateway API.
All right, let's set the scene. You've done all the hard work, right? Your app is containerized, it's humming along nicely inside your Kubernetes cluster, but now you hit that classic problem. How do you actually let people use it? How do you get traffic from the internet to your app? And more importantly, how do you do it securely without building some crazy, complicated Rube Goldberg machine of configs?
Well, the great news is, Kubernetes finally has an official built-in answer for this. It's a next-generation solution that acts like a powerful, super intelligent new front door for your entire cluster.
And let's be clear, this isn't some random third-party tool you have to bolt on. This is coming straight from the Kubernetes team themselves. They are officially saying that the Gateway API is the future, and it's built to replace the older, kind of clunky ingress system we've been using for years.
So what is it really? You can think of the Gateway API as a standardized blueprint for that smart front door. It's basically a set of rules and resources inside Kubernetes that give you a ton of control over how traffic gets into your cluster and where it goes. It's powerful, it's flexible, and it's designed for how we build apps today.
Okay, enough talk, let's actually build one. We're going to start with a super basic setup, just to get that front door installed and get some traffic flowing.
First thing we got to do is choose a gateway class. Think of this like picking the model of front door you want. Do you want a standard one, a fireproof one with extra locks? Here, in Google Kubernetes Engine, we're picking the GKE L7 Global External Managed class. It's the top-of-the-line model, built for global traffic and absolutely packed with features.
Next, we actually create our gateway with this little piece of YAML. It's so simple. We just give it a name, tell it which gateway class to use, that fancy one we just picked, and then we tell it to listen for regular web traffic on port 80. We apply this config, and that's when the magic starts.
And bam! This is the magic. The second we created that gateway resource, GKE's controller jumped into action. It automatically went out, provisioned a powerful Google Cloud load balancer, and assigned it this public IP address. Just like that, our front door is installed and has an address on the internet. No manual setup needed.
Okay, our front door is up, but right now it's wide open. All the traffic is unencrypted HTTP, and that's just not going to fly on the modern web. So let's add some locks. Let's add the HTTPS shield. Getting our gateway secured with free auto-renewing TLS certificates from Google is basically a four-step process. Don't worry, it's way easier than it sounds. Let's walk through it real quick.
First up, we just have to prove that we actually own the domain we want to secure. Google gives us this unique code, and we just have to add it as a special record in our DNS settings. It's a quick, one-time thing that basically says, yep, this domain is mine.
Once Google knows we own the domain, we can ask it to generate a certificate for us. What's super cool is this can even be a wildcard certificate to cover all our subdomains. Then, we take that certificate and put it into what's called a certificate map. You can just think of this as a secure keychain that holds all the keys our gateway will need.
And finally, we just connect it all together. We go back to our gateway YAML file and add this one single line, an annotation. This little line tells our gateway, hey, from now on, use the keychain name Test Gateway API for all your secure traffic. And that's it. We have full, auto-renewing HTTPS encryption.
Okay, so now we have a locked, encrypted front door. That's great. But what if we could give that door an entire state-of-the-art security system with cameras and alarms? This is where it gets really cool. We can attach a web application firewall, a WAF, to actively block common cyber attacks before they ever get near our app. Now, to prove this works, we need a guinea pig. So we're going to deploy the famous OWASP Juice Shop. It's a web app that was intentionally built to be full of security holes. It's the perfect target to test our new security system.
And the attack we're going to launch is a textbook SQL injection. By just typing this weird little string of characters into the login form, we can trick the database on the back end and log in as the admin, all without a password. So, let's see what happens.
And here it is, the moment of truth. On the left, before we turn on the WAF, the attack works perfectly. It sails right through and we're in as the admin. But then look at the right. The moment we flip the switch on the WAF, that exact same attack is stopped cold. The gateway sees that malicious payload, slams the door shut, and sends back a forbidden error. The attack doesn't even get a chance to touch our application. So how did we pull that off? It was just 3 simple steps, all managed right from inside Kubernetes. We created a Cloud Armor security policy. We told it to use a pre-built rule that knows how to spot SQL injections. And then, and this is the key part, we used a special GCP backend policy resource to attach that security policy directly to our application's backend service.
Blocking one of the most common attacks on the web is obviously huge. But honestly, we're just scratching the surface of what you can do with this new model. So let's take a quick look at what else is possible. Using these same kinds of policy objects, you can unlock all sorts of advanced features. You want to automatically redirect all HTTP traffic to HTTPS? There's a policy for that. You want to define super specific health checks for your app so the load balancer knows when it's unhealthy? There's a policy for that too. You can manage global security settings, advanced traffic splitting for canary deployments. The list just goes on and on.
So I think the takeaway here is pretty clear. The Gateway API isn't just some small update to Ingress. It's a massive leap forward. It's a completely integrated, super configurable, and security-first foundation for how we manage network traffic in Kubernetes. It brings the power of a cloud-native load balancer right into your cluster and lets you manage it with the same tools you already know and love. So it really leaves you with one question. Is your application's current front door this powerful?